We have learned the 6 trigonometric ratios. Now let's see how we use them in our day-to-day life of calculating the distance between two objects, or distance between two places, or distance from the place where we stand to the stars, very often used by the astronomers, or you can say the angle subtended by an object which is above or below us at a point on the ground. Okay, all that we are going to see in application of trigonometry. Now, there are only 3 terms that we need to be familiar with this. First one, in heights and distances, as I said, 3 terms to be familiar. First one, the line of sight or the line of vision. So let's understand this way. Now, I'm here, I'm looking at you, or I'm looking at an object, right? That object could be above me or it could be below me. Now, if this is my eye, this is the horizontal. Through my eye, visualize I'm drawing a horizontal line that would be parallel to the ground. The height is negligible until unless it is mentioned so. Okay, so through the eye, visualize a straight line, that is the horizontal. Now, if the object is above, right, we join an imaginary line, visualize an imaginary line, right, joining the object to the eye. So the object is above, this angle subtended at this eye, that is called as angle of elevation. Suppose the object is below, somewhere here. So visualize a imaginary line, right? The angle subtended by this imaginary line with the horizontal, that is called as angle of depression. Now only 3 terms to remember in this. 1, this is the horizontal line. The object is above, the line joining the object and the eye, that is called the line of sight or the line of vision. And the angle between the line of sight and the horizontal, if the object is above, becomes the angle of elevation. If the object is below, it becomes the angle of depression. Okay, so just look into this one. Let's say this is, we are observing from here and there is some object right opposite to it. So the height of the person or the observer is neglected. So through the eye, we just call this as the horizontal line. So imagine an imaginary line joining the top and the eye, which is called as a line of sight. Now, so let's say we have a plane and we are trying to visualize or look into the plane standing on the ground. Height, as I already said, negligible. Okay, so this is the horizontal line, the imaginary line joining the object and the eye of the observer, that's called the line of sight. The object is above the observer, so this angle is going to be called as the angle of elevation. That's the angle of elevation. Next, suppose the object is below the observer, right? So this is the horizontal and the object is on the ground. So here, as we see, the person is standing on a building. Assume it that way. So from the eye of the observer, that's the horizontal line. From there, we is observing an object which is on the ground. The line joining the object and the eye, that is the line of sight. The object is below the observer. So this angle made by the line of sight with the horizontal, that is called as angle of depression. Okay, only 3 terms. 1, the horizontal line, lying through the eye, parallel to the ground or on the ground. The object is above, the line joining the eye and the object, right? That's called as the line of sight. If the object is above, the angle between the line of sight and the horizontal is called as angle of elevation. And if the object is below, then we call it as angle of depression. So one small example, how to do these kind of sums. Let's consider an example. From an aeroplane vertically over a straight horizontal road, the angles of depression of 2 consecutive milestones on opposite sides of an aeroplane are observed to be alpha and beta. Find the height of the aeroplane above the road. So let's consider 2 milestones A and B, which are on either side of the plane P. So the distance between these 2 is 1 mile or 1 kilometer, or we'll just say it as 1 unit. Okay, now this is the point of observation. So from this point, the milestone observed here is making an angle of depression alpha. Now these two being parallel lines, this is the horizontal line as we know, this is a line of sight, this angle is going to be alpha because the two lines are parallel. Now from P we are observing the second milestone, right? So this becomes the line of sight, horizontal, this is the angle of depression beta. So two parallel lines, this angle is beta. From this point P, let me drop a perpendicular, denote this point as Q. This length AQ is X, length QB is Y. So X plus Y equals to 1. Right? So all this, I'm going to just put it this way. Once again, this is the point of observation, that is from where? From the plane we are observing, there is one milestone here, one milestone here, and the distance between them is 1. That is, from P, if I drop a perpendicular, this is Q, right? Foot of the perpendicular is Q. I need to find the height of the plane from the ground. What are the conditions given? From this point, the angle of depression of this milestone is given to be alpha, so this is going to be alpha. Angle of depression of this is beta, this is going to be beta. So just summarizing them. So this length AQ, let's take it as X, QB, let's take it as Y, with the condition that X plus Y is nothing but 1. Okay. Now we have two triangles. We are dropping a perpendicular from P, so that gives us two triangles which are at right angles, right? A right angle triangle. This is right angle. So from this triangle, if we observe, this is the given angle alpha. So with respect to this given angle alpha, this becomes the adjacent side, which we called it as the base, and this becomes the opposite side, right, which we call it as the perpendicular. So we have opposite and adjacent, perpendicular and base. So from this I can write tan alpha, that is h upon x. Okay. Next, from this triangle we have the given angle to be beta, adjacent side is nothing but QB, the value is Y, and the opposite, that is the perpendicular, which is nothing but h. So again we can make use of the trigonometric ratio tan beta is h by x. So coming back to this, so what did we say? A and B are the two milestones. From P you drop a perpendicular, PQ be h, that is what we need to find out. Let AQ be x, QB be y. Now take this triangle AQB. From this triangle, tan alpha is going to be h by x. Okay. Now tan alpha reciprocal, if I have to write 1 by cot alpha, right? Or I can say cot alpha directly. Cot alpha would be reciprocal of tan. So just flip this and write. So cot alpha is nothing but x by h. Same goes with this triangle. From this triangle, tan beta is h by y. So cot beta, flip this, so it will become y by h. We just numbered the equations 1, 2 and 3. Now add these two equations, 2 plus 3, that is add the LHS and add the RHS separately. Cot alpha plus cot beta equals to x by h plus y by h. Now we need to simplify the RHS. Here the denominator is same, h. So just add the numerators. So x plus y by h. But from equation 1, what do we have? X plus y is going to be 1. 1 upon h. Now from this I can write these two. Right? Take the reciprocal, h is 1 upon cot alpha plus cot beta. Again from the trigonometric ratios we have cot alpha is 1 by tan alpha, cot beta is 1 by tan beta. Take the LCM. Tan alpha into tan beta would be in the denominator. So check, this would be tan beta plus as it is, this into 1, that is tan alpha. I can write it as tan alpha plus tan beta. Now take the reciprocal. So tan alpha, tan beta by tan beta plus tan alpha, or this is as good as writing tan alpha plus tan beta, makes no difference.